Video. GC. Video. Learning. Guidance. Community. Pressure swing adsorption plant.
The most common system utilized for the production of nitrogen on ships is an air separation process. This system works by separating air into its component gases by passing compressed air over hollow fiber membranes. The membranes divide the air into two streams. One is essentially nitrogen, and the other contains oxygen, carbon dioxide plus some trace gases. This system can produce nitrogen of about 95 to 97% purity. The capacity of these systems depends on the number of membrane modules fitted and is dependent on inlet air pressure, temperature, and the required nitrogen purity. In this video, we will get acquainted with the operation of the PSA plant. Thank you for trusting us and watching the training video on the VLGC platform.
The PSA, or we call it also the pressure swing adsorber, and we actually have the nitrogen generator. So before anything else, what is PSA for? Or the N2 generator itself. So the N2 generator is the one generating
N2, this is nitrogen.
Yes. So a nitrogen generator, and at the same time it is also purging also of breathable air. Now it can release breathable air or nitrogen depending on the selection you're gonna have.
So you have two modes, yeah? Dry air and nitrogen.
Nitrogen.
Okay, for which purpose you are using this?
So for which purpose is mainly for purging of cargo tanks, or we actually needed an inert condition on particular spaces where this is actually connected. So sometimes for the hold space we need to put dry air.
When?
If there is actually a particular need for it because of the dew point getting less, or the pressure itself is actually lower, if in case there will be a failure for the automatic supply of the fresh air coming from the engine. So we'll be needing the assistance of the dry air that is being generated by the PSA itself. So this is actually making us a medium in between this nitrogen. So from the hydrocarbon going to the breathable air, you have to make a medium or a median of it between, and this is best done with nitrogen. And with nitrogen, you're actually blanking off. For example, the hydrocarbons, you're actually blanking off to a very specific limit or lower than the LEL as much as you can, so that in the next phase of breathable air, you will be able to have an almost explosion-free atmosphere. Same goes when you come from breathable air and you wanna permit another hydrocarbon. So you'll be putting again nitrogen as a median between the breathable air and also the hydrocarbon itself, so we can actually meet once again when it comes to the LEL content, the hydrocarbon content, which is acceptable and being presentable for the charterers.
Okay, understood.
Yeah.
And when you start blowing with nitrogen in the tank, you are setting, what is the setting will be?
So normally, if it is about nitrogen, for the hydrocarbon going to breathable air, just in case.
Yeah.
So normally it is the gas tech or maybe particular requirements, but normally industry standard we have 4%, not more than 4%. So within the 4%, whatever the flow it is, as long as you get this purity, then it is good to go. Maximum purity, maximum flow for a purity which is required. For example, we just require 3.8%, then so be it, you'll be finding it through the flow meter, and then adjust the flow, whatever can be done in order to meet this purity.
Alright. So could you show me please how to start, how to operate, and
Yes,
which button we must press, and try to teach people
Sure.
who is download this video.
Yeah, no problem. So the very first place, we are here outside the forecastle. Inside the forecastle is actually where the PSA room is. So you can have it here.
Thank you.
Now, before anything else, always safety first. Open the door, open all the ventilations. We actually have, for the bosun store, the space just before the PSA, and also the PSA mushroom vent itself. Okay? So in the design of this vessel, we actually have to start two exhausts and supply fans. Now, it is being started before everything else. Open the mushroom. And then we will be starting it in this switch. Okay? located here.
Okay.
So the one in the left side is actually for the PSA, the one in the right side is for the bosun store supply.
Okay, so we can go inside, yeah?
Yes.
All right.
So this is for the entrance of the PSA room. This space that we are now is the bosun store. That's why we will be needing also the supply fan or the exhaust coming for the bosun store. Now, prior to the entering of the PSA room, make sure, we have it here, a pre-entry oxygen alarm. So make sure it is within parameters. Now it is 21%. It's actually about 20.9. So this is an acceptable range. So if we are already sure, then we can actually proceed to the PSA room. Okay, so for the main layout here, we actually have the PSA plant cooling. Okay. We have the cooling seawater for the PSA plant, and this is the PSA itself. Okay, so this is what generates nitrogen, or if we have to bypass it, and we have a selector switch for dry air, so it doesn't need to pass on the adsorbers. So inside the emergency fire pump is also where you can locally start the PSA seawater. This is the air compressor. And this is the air dryer. So the air compressor is actually for the generation of air, sucking the air that is in here through an air intake, and then this is being processed before it is being thrown to the air dryer, which actually lessens the dew point as much as it could before throwing it directly to the PSA, because any permission of water to the adsorbers makes damages that are irreversible. Okay?
Foremost, you have to ask permission from the engine room and requires power because this is considered a high consumer ship. So you need to add one generator. Once that finished, we have to secure first the cooling. So here we have a dedicated seawater for cooling of the PSA plant. Make sure that the inlet and the outlet valves are open, and then you can start. Once the cooling is running, we can now start the compressor. But first, open the vents to release the stored any air in the system. So the compressor will not have a hard time building up pressure.
So first step, it's will be what first step? Step number one.
Step number one is power.
Power.
Yeah, for power. Additional power.
Okay, second step.
Second step is cooling water.
Switch on cooling water.
Yeah, switch on cooling water.
Okay.
This is for the compressor and for the refrigerant dryer.
Second step.
Third step is open the drain valves. One of the drain valves are here.
Oh yeah.
You have to open this first. Maybe there's water left inside the system. And then test first the auto drains. We have auto drains on that side. The system. So you have to manually activate it. So any water inside can be drained. Next, once all of that is prepared, you can now start the compressor, the air compressor. So we have power, and then we have cooling, and then you just have to start this one. Once it starts, there will be build up pressure. So once we have pressure, we can now start this air dryer. We can start this air dryer using this switch to number one. We can use it local. And then Once we have pressure and the air dryer is running, we can proceed to the PSA. PSA. We have pressure and we have dryer running.
Okay.
So here we have to maintain 8 bars. Going to the PSA. All the valves are closed. And then we have to stabilize first the pressure in the system. We have the buffer tank. And then we have the inlet pressure. It needs to be at least 8 bars. Yeah. Then, guys,
So we gotta go along the processing. So we're already well informed when it comes to the startups. Now I will show you how the process flows. Okay. So initially, as per second engineer already instructed, power first, then the seawater cooling for the air compressor and the air dryers, and then we'll be ensuring the startup of the compressor and then the dryer, and then here. Sometimes it is also advisable to have the air dryer already started beforehand, so it can already build the momentum in order to reduce the dew point that is within the system alone before permitting the air itself. So we're gonna start first with the air compressor. Air compressor. So ensure that we already have the fan, correct? Now all the built atmospheric air in the space will be suctioned here in the air intake. Here. This is the air intake. Yeah. Now it's actually a hollow space, but towards there is actually the intake for the compressor. Okay? Now in here, please. With the air intake already running, it will be processed into the compressor to make it compress there.
Okay lang din naman.
Then the compressor will actually go to coolers. There's actually air and oil coolers. Now, for the oil coolers, we already know the purpose of it. It's actually lubrication and also capacity control. And when it comes to air coolers, it is actually an initial method, initiative of the compressor in order to drain excessive water or moisture. And then, when it is being released, before it is passed down to the dryer, you can have it here. You can actually see a particular vessel. This is actually called a cyclone separator. Now, if you're gonna follow the process flow of the pipings, it will be generating here and following this line, and it shall go to the cyclone separator. So the cyclone separator's purpose is actually draining also excessive moisture that wasn't being dried on the air cooler alone, so that we can actually mostly guarantee that air is being dry or moist less when it comes being fed to the dryer. Now, the momentum of this will make actually a cyclone effect, so that's why we actually have an auto drain. It actually auto drains any condensate into the bilge. Then, after pure air, lesser moisture, already processed in the cyclone separator, it proceeds directly to the dryer. Now, if you're gonna follow this one, the one behind, it's actually gonna come inside the so-called evaporators. And then in the evaporators, it is where the refrigerant also is also passing by in order for the exchange, in order to take out excessive moisture within the air before it is driven outside. And then when it's driven out, this will be the line of it. We actually make sure as much as possible to have a dew point of 3 degrees or lesser. And that is being detected by this thermometers in here. So, and this one. Okay? Right? So the delivery is actually this one. And then we're gonna follow the entire line. And then goes to the air filter once again. Okay? So this is actually an additional filter of the air that is being delivered. We are almost guaranteed that the dew point of the air being produced from the dryer is actually already dry, but it is actually an additional instrument for further drying. Then being processed into the oil absorber, because normally that will separate by gravity. Oil will be accumulated down, air proceeds into the dust filter. So any accumulation of dust, if there is any, it will be filtered here. Okay? So both the air filter and the dust filter actually have a lifetime. It can also be seen through this one. Okay? So that is also indicating if the dust filter is already too polluted or too much of it to handle for the filter. Then being processed and released all the way to the control buffer, where it actually controls the impact of the excessive pressure before it is driven into the PSA itself. Now we have to condition first. We do not permit any air that has a dew point more than 6 degrees. Anything more than 6 degrees will actually damage the CMS, carbon molecular sheaves, that is doing their job for the nitrogen generation. And that if it becomes wet, the nitrogen generation will actually become poor already. So you will be requiring lesser flow. Where in fact, the design specification for this one, you can actually have 0.3% of purity at 520 flow rate. But if we have problems when it comes to the CMS, it will actually become lesser and lesser. Yes, carbon molecular sheaf. Now these are actually carbon molecules, carbon particles that is being filled inside these tanks. So whenever dry air comes, actually these carbons are the one acting as the one attractive for the oxygen to retain in order for a pure nitrogen going out into the outlet. Okay? So again, we do not permit anything above 6 degrees. Now, how do we reduce the dew point? Yes, we've already reduced it at some point in the dryer, but we have to further reduce it to be sure. And that can be done through a bypass valve. In this bypass valve, it is where you're gonna have, from the supply of this, you actually have an option to direct it already to the PSA, and another one here, which actually goes directly into the atmosphere. So, bleed everything to the atmosphere, release everything to the atmosphere until you are certain that the dew point is already lesser before you actually shut it, and then we can already operate the PSA. When we met already the 6 degree criteria, this will flicker. The start button, and when that flickers, acknowledge all alarms first. Ensure what do you need? Do you need the air purging or the dry air? So for this case, let's just say it is N2. We require the nitrogen. We have it in here, off, which means this is for N2 supply. And then the flicker starts. You press the button, start. And the nitrogen generation will initiate.
Thank you so much.
Yeah, okay. Thank you.
We saw the startup process and learned how the PSA plant works. If you have any questions, you can always discuss them in the professional chat on our platform. Thank you for watching this video. You have taken another step towards safe work on gas carriers.
VO GC Video Learning Guidance Community